Hey, today guys, we're going to be talking about distributing and combining like terms. So let's get back to what distributing was all about. We had a number outside the parentheses, and then we had a sum or difference on the inside of the parentheses. And what we're doing is we're multiplying what's outside to both terms that are on the inside. So when I've got this problem, 5 times the quantity of 6 plus x, and then plus 3 on the outside of the parentheses, I'm going to have to distribute first, then combine like terms. So in the past, we've written out each small step. I would write 5 times, maybe if my marker works, 5 times 6 plus 5 times x. But I'm skipping that step. So I already know that 5 times 6 is 30. I don't have to write those small in-between steps anymore because I've got my multiplication skills down. So I've got 5 times 6 is 30. 5 times x is 5x. So that's where those two terms come from. And then I'm just bringing down this plus 3x. Once I've got this step right here, I can go ahead and combine my like terms. I've got x's with x's. I'm going to put them together. 5 plus 3 is 8. Remember when we talked about combining like terms, we want our term with the variable in front. If we have more than one variable, we want them in alphabetical order. So in this case, we've got our term with the variable in front, 8x, and then our constant behind it, plus 30. 8x plus 30 is our final answer. We can use the commutative property of association to help us do that. So that is our simplified answer. Example 2, we've got a similar scenario going on, except our distributing is in the second part or the second half of our problem. It's back here. It's not up front, but we're still going to attack it first. So I'm going to multiply 5 times a, which is 5a, and 5 times 3, which is 15. So I write that down, and as you can see, I've got like terms with my first and my second term. I'm going to go ahead and put those together. 2a plus 5a makes 7a's, and I just bring the minus 15 down. It's minus 15 because I've got a minus sign here in front of the 3. So I need to continue to bring those operation symbols down with the problem. My final answer is 7a minus 15. Here we've got a situation where I've got two distributing problems in one. So I'm going to have to take care of each distributing scenario before I start combining like terms. I cannot combine like terms until I've completed the multiplication part of my problem. When we use PEMDAS, the multiplication comes before the addition and subtraction. So just like in PEMDAS, in order of operations, I've got to complete my multiplication first before I can add or subtract. So if I distribute the 3 to the x and the 3 to the y, I've got 3x plus 3y. If I distribute the 7 to the 2x, that gives me 14x's. If I distribute the 7 to the 3y, that gives me 21y's. And it's important to have two different colors, remember from before, where we can circle the like terms in a certain color and maybe use squares for the other like terms so that we can identify what to put together. We always box in or circle the operation symbol that comes before the term. So in this last term, I boxed the addition sign that came before the 21y because that helps me know how to combine. For example, 3x, that's a positive 3x, and I have 3x plus 14x. If I didn't circle that plus sign, I wouldn't know whether to add them or subtract them. So that information is critical to our problem. 3x plus 14x is 17x. Positive 3y plus 21 more y's altogether would be positive 24y's. Again, if I didn't have those operation symbols identified with the term, I wouldn't know whether to add or subtract, and I could possibly get an incorrect answer. So our final answer is 17x plus 24y. Again, try to have some colored pencils with you or some highlighters so that you can do that on your paper. In number 4, I'm going to do this with you. I have 11 times the quantity of 2c plus d plus 6 times the quantity of c minus d plus 6. So I've got 2 sets of distributing, and then I've got a constant at the very end of my problem. So if I distribute here, 11 times 2c is 22c. 11 times 3d is 33d. And there's a plus sign in between them. Plus, and then I have to do distributing again. 6 times c is 6c, and there's a plus 6c. 6 times a d is 6d, and look here, there's a subtraction sign in front of the d. I need to bring that down in front of my term. And then on the end of my problem is a plus 6. Well, let me go ahead and start circling and identifying my like terms. 22c's plus 6c's. Let's see if this black one will work. I've got positive 33d's, take away 6d's. This constant is the only one of its kind. There's nothing that I can combine that constant with. It does not have another constant to go with. It has no like terms. So 22c's plus 6 more c's is 28c's. Then I've got 33d's, take away 6d's. 33 take away 6 is positive 27d's, and then I just bring this down, plus 6, because there's nothing else to combine it with. If I take a look at my final answer, I've got 28c's plus 27d's plus 6. In my final answer, I have nothing else that I can put together. So that is it. It is as simple as possible, or it is simplified. Here I've got some more examples. They are our special cases, or our special scenarios. So I've got a y out front. I've got a variable out front now. I'm going to have to multiply that variable by my 2 terms on the inside of the parentheses. That's a little different. So I've got y times 3. We don't really write our answer out like this. We do not write our answer like this. If we've got y times 3, we're going to use that 3 as a coefficient. Okay, we're going to use that 3 as a coefficient and put it in front of our y. It still represents those other things I wrote down, but it's in a more efficient way of writing. So instead of writing y3 or 3.y, I'm going to write it like this. That's the most efficient way to write a term. Then I've got y times z. I don't know what y is, I don't know what z is, but I know that I'm multiplying y times z, so I'm going to just write that. That's all I know, and that's all I can do with that problem. This is my final answer, 3y plus yz. When I find out what y is or represents, I can put it in there and I can maybe calculate something. But as of now, this is as far as I can go. This is as simple as it gets. Here in question number 2, I've got m times the quantity of m plus 12. Again, I've got a variable on the outside of the parentheses. So I've got to multiply that variable by everything on the inside. M times m plus m times 12. So here I've got it written out. Let's think back to when we were talking about exponents. When we were talking about exponents, we often talked about m times m. If you have m times itself, a way to shorten that would be to write m squared. So we're simplifying. We're writing this as simple as we know how, and this is how we would write it, m squared. M times 12, remember the simplest way and the most efficient way is to write 12m. So our final answer is m squared plus 12m. And then example 3 I'm going to do with you. We've got yz squared plus y times the quantity of z squared plus 7. So I've got to distribute first. So I'm going to draw my arrows. Y times z squared is just y z squared. Y times 7, that's just 7y. And then I'm going to bring down what I didn't use, y z squared. Now I'm going to look to see if I have any like terms. Yz squared plus yz squared, those are actually like terms. What's their coefficient? Well, if there is no coefficient visible, then the coefficient is technically a 1. So I've got 1 yz squared plus 1 yz squared. How many yz squareds do I have altogether? I've got 2 yz squareds altogether. This is not like this, so we've got to just bring it down. And my final answer is 2 yz squareds plus 7y. It looks kind of complicated, but all in all, this is the simplest form that you can get. I would like you to write down these problems and try them for homework. Bring them in tomorrow and we'll talk about them.